Good morning, students. Sorry for the delay now. Let's start the lesson. So, yesterday we discussed about the frog, the various components of the internal anatomy. That means the various systems regarding the circulatory system, etc. Let us pass on to the next system, excretory system. Now, you know the meaning of excretion, the process of elimination of nitrogenous waste products from the body. Process of elimination of nitrogenous waste products in the body is called excretion. The system which is involved in this process is called excretory system. Now the excretory system consists of number one, a pair of kidneys, then a pair of ureters starting from the kidney. The ureters open into a chamber what is called cloaca. And there you have connected to this ureters, we have a bladder called urinary bladder for storing the urine. So from where it is being stored in the urinary bladder, then discharged into the cloaca and finally opens outside through the cloacal aperture. Now about the kidneys, very simple in organization, not looking like the kidney of man. Now these are dark red colored bean shaped structures. Dark red colored bean like structures, very compact in nature and situated posteriorly in the abdominal cavity on both the sides of the vertebral column. Okay, no specific region for abdomen, simply we can say trunk, otherwise we can say the body cavity. So very compact dark red and bean like structures situated a little posteriorly in the abdominal cavity, or we can say in the trunk cavity or body cavity. Present and one on either side of the vertebral column. Now each kidney is composed of a number of units. The units of kidney are called the nephrons. Otherwise called uriniferous tubules. The common name for this one, uriniferous tubules. The unit of function of kidney. The unit of function of the kidney. The structural and functional units of kidney is called the nephron. They are responsible for filtering what we call the waste products from the blood and sending out in the form of urine. Now, the type of kidney in the case of frog is called mesonephric type, mesonephros. I mentioned about we have different types of kidney based on the place of origin. So during embryonic development, suppose it's the anterior parts of the body, the posterior parts of the body. In some cases, the kidneys are developed at the anterior end. Then it's called pronephric kidney. In some cases, the kidneys are developed in the middle part of the body. They are called mesonephric. In the case of reptiles, birds and mammals, the kidneys are formed at the posterior end. Then it is called actually metanephric kidney. So pronephric, mesonephric, metanephric kidneys. These are the different types of kidneys. Now in frog, the kidneys are developed in the middle part of the body during embryonic development, hence called mesonephric kidney. Mesonephric. Even in the case of fishes also become mesonephric. Now, there are 4 pairs of renal arteries. A pair of renal portal veins supply blood to the kidney. So, a pair of renal portal vein that is coming from the leg region and opens into the kidney. That is called renal portal vein. One from each leg and opens into the kidney. That is called renal portal vein. So there are 4 renal arteries on either side of the dorsal aorta. So we have together 4 pairs of renal arteries. What is in the case of arterial system? 4 pairs of renal arteries supply blood to the kidney, and a pair of renal portal veins supplies blood. Actually just collects blood from the kidney. Normally renal portal veins supply blood to the kidney. The meaning for that one, this portal vein starts in capillaries in the leg region and ends in capillaries in the kidney. Such a vein is called portal vein, you know that one. As the kidneys are involved, it is called renal portal vein. So, 4 pairs of renal arteries and a pair of renal portal vein coming from the posterior parts of the body, particularly from the leg region, supply blood to the kidney. Now, actually, from the kidney, the blood is collected by the post-caval vein through 4 pairs of renal veins. So 4 pairs of renal veins collect blood and 4 pairs of arteries supply blood along with a portal vein, a pair of portal veins coming from the leg region. They supply the venous blood, from where actually the blood is collected by what we have the 4 pairs of renal veins. So 4 pairs of renal arteries and 4 pairs of renal veins and a pair of renal portal vein collecting blood from the leg region and opening into what we have the kidney, hence called as a renal portal vein. Starts in capillaries in the leg and ends in capillaries in the kidney, hence called renal portal vein. Now that's about the kidney. So dark colored vein shaped structures, very compact in organization, present at the posterior parts of the body, and they are made up of the structural and functional units called the nephrons, which separate the waste products and eliminate it in the form of urine. Now the blood supply to the kidney, there are 4 pairs of renal arteries and a pair of renal portal vein coming from the posterior end of the body from the legs, collecting blood from the legs and opening into the kidney. And from the kidney the blood is collected by means of 4 pairs of renal veins, what is in the case of venous system. Then we can have the ureters. Now from the outer margin of each kidney there arises a ureter, a tube. Now in males, as it performs the function of carrying both reproductive and urine, it is called urinogenital duct. So it not only transports the waste products but also transports the reproductive materials, as in the case of all vertebrates including man. It is called urinogenital duct. So ureter simply passing the urine. But in the case of male, it collects not only urine from the urinary bladder but also transports what we have the sperm. Hence called urinogenital duct. Urinogenital duct. In females, there are separate ureters and separate oviducts which open separately into the cloaca. There are separate ureters, there are separate oviducts which open into the cloaca. Now the cloaca, it is nothing but a chamber into which the various ducts open. Now ureters of both the sides extend posteriorly and open into the cloaca, which opens out through what is called the cloacal aperture. So the ureters open into the cloaca, and from where there is nothing but a chamber, from where the urine is entered through urinary aperture. Now the urine is being stored for a short while in a bladder-like structure, what is called urinary bladder. Now this is normally a thin-walled urinary bladder present ventral to the rectum, which also opens in the cloaca. So the ureters open and then the urine is being stored for a while before it is being eliminated in the urinary bladder, and it's a thin-walled chamber present normally ventral to the rectum and storing the urine and discharging the urine outside. Now the waste product in the case of frog is urea, hence frog is called ureotelic animal. So we too, the mammals also ureotelic animals including man. So frogs and mammals together eliminate urea, hence both are called ureotelic animals. Both are called ureotelic animals. So remember that one. What is the nature of the waste product in the case of frog? Now let us take about the reproductive system. So along with the reproductive system, I will show the picture of the kidney and other structures associated. Now the male reproductive system consists of a pair of testes. Normally, these testes are yellowish ovoid bodies. Yellowish ovoid body. And each one is attached to the anterior end of each kidney by means of a connective tissue. So anterior end is nothing but the upper part of the kidney. See, they are found attached to or adhered to the upper part of the kidneys by a double-fold peritoneum. By a double-fold peritoneum. That is what we have the connective tissue lining what we have the cavity along with the ciliated epithelium or the coelomic epithelium. So a double-walled or double-fold peritoneum, and that one is called as a mesorchium. So the testis is attached to the anterior end of the kidney or top end of the kidney by a double-fold peritoneum. The name of the peritoneum is called mesorchium. Now from the testis, nearly 10 to 12 minute ducts, fine duct tubes. They arise from the testis, and they are together called as vasa efferentia. The minute ducts, 10 to 12 in number, arising from each testis, are called vasa efferentia. Singular vas efferens, plural vasa efferentia. Now these vasa efferentia from the testis, the present one outside the kidney, they enter in the kidney and open into the canal. The name of the canal is called Bidder's canal. This is one question. From the testis, minute tubules or ductules arise. They are called vasa efferentia. They are leaving the testis and enter into the kidney, and inside the kidney they open into one canal, what is called the Bidder's canal. And finally, from the Bidder's canal, it communicates to the exterior through what is called the urinogenital duct. Urinogenital duct. Now this is a urinogenital duct. Now this is the connection. Vasa efferentia. Vasa efferentia. So they open into the Bidder's canal. The Bidder's canal present actually inside the kidney. The Bidder's canal present inside the kidney. The Bidder's canal proceeds as what we have the urinogenital duct. It opens into the urinogenital duct. The common passage for urine and the reproductive materials. This is the arrangement. So vasa efferentia, connecting duct from the testis to the kidney. Now inside the kidney we have the Bidder's canal. The canal is present inside the kidney. This one is present inside the kidney, and which receives the sperm through the vasa efferentia from what we call the testis, and finally opens in the urinogenital duct, the common passage for the elimination of both urine as well as what we call the reproductive materials. So finally it communicates with the urinogenital duct. Now in male, the urinogenital duct normally actually what we can say mesonephric duct. It is developed from Wolffian duct. The urinogenital duct of male is also called as Wolffian duct after the name of the person. So this is one question. The urinogenital duct arises from what we call mesonephric duct. That mesonephric duct, there is nothing but from the kidney. The urinogenital duct is nothing but the ureter that arises from the kidney. That is also called as a mesonephric duct. That mesonephric duct is called a Wolffian duct. That is the one responsible for the transfer of the reproductive materials outside. So anyway, remember that one. The urinogenital duct is also called as Wolffian duct in the case of male frog. Another name for urinogenital duct, also called by name mesonephric duct. This is what is happening normally. The urinogenital duct develops from the mesonephric duct during embryogeny, or we can say it arises from the Wolffian duct. The name given during development, the urinogenital duct is called Wolffian duct. So the urinogenital duct develops from Wolffian duct during the embryogeny. That's why another name for the urinogenital duct, Wolffian duct. Now this is the arrangement. You see that one about the male reproductive system, very similar organization. Also you can see here the excretory system. I didn't mention about them. Now this is what we call the excretory system, a pair of kidneys, and this one a pair of ureters together called urinogenital duct, and then the opening of urinogenital duct into the cloaca, and there you have here the urine that opens here is collected in the urinary bladder. This is the urinary bladder. Regarding the excretory system, a pair of kidneys, a pair of urinogenital duct in the case of male, and they open separately into the cloaca. Now this is the cloacal chamber, and this is the cloacal aperture. This is the aperture. This is called cloaca or cloacal chamber. If you are using the word cloaca, that's not the opening, it is a chamber. So into which the reproductive and we have what is called actually the excretory and the digestive systems open. Now the urinogenital ducts separately open into the cloaca, and now this is the opening of the urinary bladder. Now the urine enters here, is being collected in the urinary bladder before it is being discharged. And after the urinary bladder is being filled with, the urine is discharged out through the cloacal aperture. So that's about what we have actually the excretory system, very similar organization. Now regarding the reproductive system, it is also associated with the excretory system. Now we have a pair of testes, yellow colored testes. These are all yellow colored testes. They are attached to what we have actually the kidney by means of what I mentioned, the mesorchium, a peritoneum, a double fold peritoneum, joining the testis with the kidney. This is number one. Now from the testis, so you see that one at the junction of the testis and the kidney, there are fat bodies. These are all the fat bodies. Finger-like fat bodies are found attached to the surface of the kidney at the junction of the testis and then kidney. Now, a number of minute ductules 10 to 12 arise from the testis. What I mentioned here, this is the one, and this is what we call the vasa efferentia, and these 10 to 12 tubules arising from that is the testis open into the kidney. They open into the kidney. There we have a canal, what is called Vidus canal, into which the vasa efferentia open. From the Vidus canal, the reproductive materials are sent out through this urinogenital tract. So, testis, vasa efferentia, Vidus canal, and urinogenital tract. Then finally, it is being discharged into what we have the cloaca, from where it is discharged through cloacal aperture. Now, I mentioned already the urinogenital duct is otherwise called as Wolffian duct. The another name for this urinogenital duct, Wolffian duct. So that means during development, the mesonephric duct develops into the urinogenital duct, what is called the Wolffian duct. Another name for that one, Wolffian duct. So that's about the male reproductive system, very similar in organization. A pair of testis, vasa efferentia, Vidus canal, and then we have urinogenital duct, and finally opens into the cloaca. Now, so if you're taking what we have actually, the endocrine system, we have adrenal gland. There is one gland. Here there is a strip, you know that one. It is attached to the kidney. We'll talk about later. We have a number of glands found in the body called the endocrine glands. They secrete the hormones. Here the adrenal gland is nothing but a strip of gland present attached to the surface of the kidney. That we'll talk about later. This is what we have here. That's about the adrenal gland. Now the female reproductive system. So again, once again, this is that one is a diagrammatic representation. This is a colored one taken from the book of NCRT. The same one, what we have, the testis, yellow colored bodies. These are all the fat bodies, what I mentioned. So here the vasa efferentia, this part, we have a number of minute tubules, 10 to 12, arise from the testis, they open into the kidney. Inside the kidney, we have what is called the Vidus canal, and the Vidus canal just open into the urinogenital duct. The urinogenital duct opens into the cloaca, which further opens through cloacal aperture. Same picture with a colored structure. Now this is the urinary bladder concerned with the storage of urine. Now the rectum also opens into the cloaca. Now the reproductive materials, the rectum, and also the urine all open in the cloaca. There is only one aperture in the case of frog, through which normally the waste materials, the reproductive materials, and urine are being sent out. Now let's go to the next one, the female reproductive system. So unlike the male reproductive system, the ovaries are not attached to the kidney. In male reproductive system, the testes are attached to the kidney. But in the case of female reproductive system, the kidneys are actually no way connected to the ovaries, or the ovaries are not attached to the kidney. They are present normally scattered, just actually in that is what we call the body cavity. Then only a few structures being attached to the kidney by means of another fold of skin. Though I mentioned that is not attached, but actually they are attached to that one, just in the middle part of the kidney, not at the anterior part. Though I mentioned just in a short way. So a pair of ovaries are situated near the kidneys, and there is no functional connection with the kidneys. What I mentioned, slightly attached. No functional connection, and there is normally there you have just from the testis we have the tubules, what we call the vasa efferentia. They open into the kidney, but here there are no connections between the ovary, the functional connection between the ovary and the kidney. There are no ducts open into the kidney from the ovary. That's the meaning for that one. There is no functional connection with the kidneys, though they are found attached to the. They are also found attached to the what we call the kidney by means of another peritoneum, but there is no functional connection between the ovary and the kidneys. There you have functional connection because of the presence of the tubules vasa efferentia. Here there are no functional connection between the between the ovaries and the kidney. Now, so the ovaries are actually just multilobed structures normally found over the kidneys, but there is no functional connection between the kidney and the ovaries. Now we have pair of oviducts present nearby the ovaries. They are not connected to the ovaries. They are found individually, independently, but differentiated into anterior funnel-shaped structure, followed by oviduct. At the posterior end, it enlarges to form what is called a oviscum. That is arrangement of the oviduct. So the oviduct opens in the body cavity through a funnel-shaped structure, what is called oviducal funnel. Then the oviduct, it enlarges to form a sac-like structure before opening to the cloaca, what is called oviscum. So this is the arrangement in the case of what we call the oviduct. So a pair of oviducts arising from the ovaries, they are not connecting with the ovaries, they open into the cloaca, separate the two oviducts. The anterior end bears a funnel-like opening. Each oviduct has a funnel-like opening at its anterior end, what I mentioned earlier. And this opening is called as ostium. The funnel-like opening of the oviduct is called ostium. It opens into the body cavity nearby the ovary for collecting the egg released from the ovary and passing it through the duct towards the cloaca. Now its posterior end swells up to form what is called ovisac. Swells up into what is called ovisac. So anteriorly it opens in the body cavity by means of a funnel-shaped opening called as ostium, and posteriorly it enlarges to form a ovisac before opens into the cloaca. And from where it is being sent out, the egg when it is released from the ovary is collected by the ostium and is transported through the oviduct and stored for a short while in the ovisac and then released into the cloaca, from where it is sent out for external fertilization. Now here is the structure. Now this is what we call the ovaries. They are found attached to the kidney by means of another peritoneal fold. See, the testes are connected to the kidney by means of what is called mesorchium. Now the ovaries are connected to the kidneys by means of another peritoneal fold, what is called mesovarium. Mesovarium. So the testes are attached to the kidney by means of a fold, a peritoneal fold, a double fold peritoneum, that is called mesorchium. And this one again a peritoneal fold connecting the ovary to the kidney, but there is no functional connection between the ovary and what we call the kidney, as in the case of testis and kidney. There you have, you see that when a functional connection means, so it sends out the vasa efferentia which are connected to the kidney. But here there are no such ducts open. There are no such ducts arise from what we call the ovaries and connecting the ovary with what is called the kidney. Simply the ovaries are connected to the kidney by means of a connective tissue. What is called a peritoneal fold. A peritoneal fold, connective tissue plus what we call coelomic epithelium. So that is called mesovarium. So in the case of testis it is called mesorchium, and in the case of ovaries it is called mesovarium, connecting the ovaries to the kidneys. Now here it is being connected by means of mesovarium. This is the ovary. Okay, now this is the kidney, the fat bodies. Now this is the oviduct. Now the ovaries are released by that actually the ovary. Now this is the oviduct. Now the oviduct is actually opening into the body cavity by means of a funnel shaped opening, and that is called as ostium. So it is a highly coiled duct running posteriorly, and before opening into the cloaca it enlarges to form what is called as ovisac. So the oviduct consists of anterior funnel shaped ostium, then the coiled oviduct, and towards the end it forms what is called enlarged ovisac where the eggs are stored, and finally the eggs are released into the cloaca, from where it is sent out through the cloacal aperture. Other organizations are similar, as in the case of what we call the male reproductive system regarding the kidney, ureter, cloaca, urinary bladder, all same in both male and females. The only difference regarding what we call the male and female reproductive system only. Okay, now, so that's about the female reproductive system, very simple, a pair of ovaries, then a pair of oviducts. The oviduct is differentiated into anterior funnel-like structure called ostium, opens into the body cavity, a highly coiled oviduct, and then posteriorly placed ovisac, that is nothing but the enlargement of the oviduct, where the egg is being stored for a short while before it is being released into the cloaca. Now the same one comparison, male reproductive system, you could see now the testes. So testes, now here this is the ovaries. Actually here it is not mentioned. This is the ovary found attached to the kidney. And then we have, this is what we call the vasa efferentia, 10 to 12. But here there is no such structures. No such structures, no functional connection between the kidney and what we call ovaries. Then we have the cloaca, the bladder, and you have the eggs that are released by what we call the ovaries are collected by this funnel, what is called the ostium, and pass on through the oviduct and stored here in the ovisac before it is being released into the cloaca. This is only the comparative diagram. The previous one I given separately, here the comparison. What for actually the male and female reproductive organs are arranged. Now chemical coordination. This is only a fundamental one because we are going to talk about soon in physiology and human physiology. Now in the human body we have actually two types of coordinating systems. And these two types of coordinating systems integrate various activities of the body. One coordinating system is the chemical coordination, another one is the nervous coordination. The chemical coordination is brought about by hormones, chemicals. The impulses are transported in the form of chemical substances called hormones. That is called chemical coordination. And also we have the nervous coordination brought about by the nerves. They carry impulses from brain to the concerned organ or from the organ to what we have actually the brain or spinal cord. Now here the chemical coordination is normally brought about by hormones secreted by endocrine glands, the ductus glands. Normally in the case of vertebrates, for example including man, we have certain glands which secrete the hormones to carry out the activities to integrate the various functions. Now as in the case of human beings, we have a number of endocrine glands too in the case of frog. The prominent endocrine glands in our body, the pituitary gland, then the thyroid gland, parathyroid gland, then we have the pineal gland present in the brain, thymus concerned with what is called immunity, and also pancreatic islets, islets of Langerhans, adrenals and gonads. Gonads also functioning as endocrine glands by secreting certain hormones, the male hormones or female hormones. So we are going to study in detail about the chemical coordination in the case of human beings. The same one will be followed here. Okay, now, so the prominent endocrine glands are the pituitary, thyroid, parathyroid, the pineal glands, thymus, pancreatic islets, adrenal glands and gonads. Almost all the glands are present in frog as in the case of man. We will talk about in detail in man. Now neural coordination. I mentioned we have two coordinating systems in the body. One is a chemical coordination, another one the neural coordination. Now the neural coordination is brought about by, that with the nervous system. If you are taking the nervous system is broadly classified into three divisions. One, central nervous system, which includes the brain and spinal cord. Two, peripheral nervous system, which includes the cranial nerves and the spinal nerves. So in the case of frog, the peripheral nervous system consists of 10 pairs of cranial nerves. This is one question. How many pairs of cranial nerves in the case of frog? And 10 pairs of spinal nerves arising from the spinal cord. So this is a question. How many pairs of cranial nerves present in frog? See, in the case of fishes and amphibians, we have 10 pairs. Reptiles, birds and mammals have actually 12 pairs. So we have 12 pairs of cranial nerves and 31 pairs of spinal nerves. But in the case of frog, the peripheral nervous system, the one which is leaving from the brain and spinal cord, deviating from these two structures, leaving to various parts of the body, the peripheral organs, hence called the peripheral nervous system. So it is being represented by both cranial nerves and spinal nerves. In frog, the number of cranial nerves 10 pairs, starting from olfactory, optic, auditory, olfactory. So we have olfactory, optic, then we have oculomotor, this is arrangement, olfactory, optic, oculomotor, trochlear, then we have trigeminal, abducens, facial, auditory, glossopharyngeal, vagus. These are all the 10 pairs of cranial nerves. Now the last cranial nerve is vagus nerve. In the case of frog, that's a question. The last cranial nerve is called vagus nerve. Vagus nerve. This is the 10th cranial nerve. The last cranial nerve is vagus nerve. That is the 10th cranial nerve. So 10 pairs of cranial nerves. The last cranial nerve is vagus nerve. The first one is olfactory. Anyway, this is the last. Actually, that one they asked in the question paper. The last cranial nerve in frog is vagus nerve. That is nothing but the 10th cranial nerve. Now there are 10 pairs of spinal nerves. We have 31 pairs of spinal nerves. Those nerves arising from the lateral sides of the spinal cord are called actually the spinal nerves. Now 10 pairs of spinal nerves, and the first spinal nerve is called hypoglossal. The first spinal nerve is called hypoglossal. hypogloss. This is the name of the first spinal nerve in frog. First spinal nerve in frog is called hypogloss. The first cranial nerve is called the vagus nerve. This question came in the question paper. The first spinal nerve in frog is called, that is what is called hypogloss. The first cranial nerve in frog, vagus nerve. Remember these two things. So 10 pairs of cranial nerves, one question, 10 pairs of spinal nerves, another question. The first cranial nerve is another question, that's a vagus nerve, the 10th cranial nerve. And similarly, the first spinal nerve is what is called hypogloss. These are all the 4 questions, remember. Now, they together constitute the peripheral nervous system, deviating from the brain and spinal cord to various parts of the body, peripheral organs. Now, another one, an independent nervous system, what is called autonomous nervous system. Autonomous nervous system. It has 2 divisions, sympathetic and parasympathetic nervous systems. These 2 systems are working antagonistic manner, there is an opposite manner, working in an opposite manner, that is called antagonistic manner. Antagonistic, working in opposite manner, controlling the smooth muscles, the cardiac muscles, the glands. So almost all the visceral organs are under the control of autonomic nervous system, independent nervous system. The smooth muscles are controlled, the cardiac muscles are controlled, the various gland secretions are controlled by the autonomous nervous system. We'll study in detail all these things in human physiology, not in the case of frog. Now about the brain. The brain is very similar in organization. It is placed normally vertically in what is called in horizontal position as the animal is moving forward horizontally parallel to the substrate. Now it consists of forebrain, hindbrain and also in between the midbrain. Now what are the components of the forebrain? So the forebrain includes 1. The olfactory lobes, paired cerebral hemispheres and unpaired diencephalon. See, we have in the diagram the picture. Now this is the arrangement dorsal view. So after this one, just what I am just drawing the diagram is the forebrain. Now the forebrain consists of, this is the forebrain, consists of, you see that one, a pair of olfactory tract, this is the nerve fiber and this is the lobe. Okay, now this is one olfactory lobe and starting from this one up to this one we have the forebrain. So the forebrain consists of a pair of olfactory lobe, a pair of cerebral hemispheres, a single median diencephalon. This is the forebrain. And if you are taking the midbrain consists of a pair of optic lobes. This is what we call the midbrain. Now in the case of frog, the midbrain is otherwise called as corpora bigemina. Corpora bigemina. Another name, corpora bigemina. In the case of human being, it is called corpora quadrigemina. There are 4 lobes. Here only 2 lobes. Now remember, the midbrain of frog is formed of 2 optic lobes. Another name for that one, corpora bigemina. Now this is what we have, the cerebral hemisphere. Then we have a diencephalon medial one. In the center of the diencephalon, we have the pineal gland. Now this is the 3rd part of the forebrain. Olfactory lobe, cerebral hemispheres, then diencephalon. In the middle of the diencephalon, we have a gland. One gland, what is called the pineal gland, producing some hormones, what is called melatonin. This is also an endocrine gland. Then we have the optic lobe. This is forming the midbrain. So the midbrain is formed of 2 optic lobes, hence called as corpora bigemina. Then it is followed by the hindbrain. The hindbrain consists of 2 components. So one, the cerebellum, another one, the medulla oblongata. One cerebellum, another one, medulla oblongata. Now I have mentioned here the 4th ventricle. Normally the brain encloses 4 cavities, what are called ventricles. The ventricles 1 and 2 are present in the cerebral hemisphere. Ventricle number 3 is present actually in the diencephalon region, and ventricle 4 is present in the medulla oblongata. 4 ventricles. We will discuss in detail in human being. It's not necessary here. You have to know there are 4 ventricles, 1 and 2 in the cerebral hemispheres, number 3 in the diencephalon, number 4 in the medulla oblongata. Now anyway, I would like to just repeat once again the forebrain, midbrain and hindbrain. The forebrain includes number 1 the olfactory lobe, number 2 the cerebral hemispheres, number 3 the diencephalon, In the center of the diencephalon, we have a gland, what is called, that is the pineal gland. Now we have the midbrain, it is being formed of what is called the optic lobe. This is the optic lobe, 2 in number, hence called corpora bigemina. Then the hindbrain is formed of 2 parts, one is called cerebellum. Now this strip is called as a cerebellum. And then we have the medulla oblongata. This is the medulla oblongata, the posterior part of the brain. Now the brain is somewhat a hollow cavity enclosing ventricles. The spaces are called ventricles. There are 4 ventricles, 1 and 2 in what we call ventricle, just actually in cerebral hemispheres, left and right. The third one is present in the midbrain, in the diencephalon. The fourth one is present in the medulla oblongata. Now if you are observing on the ventral side, we can see a crossing of what we call the optic nerves arising from the 2 optic lobes, one from each, so they are crossing each other. So the right one and left one, the optic nerve arising from the left and right optic lobes, they cross each other on the ventral side. This crossing of optic nerves arising from the optic lobes is called optic chiasma, overlapping, just like a cross. And from the base of it, there is a formation of hypothalamus. Now the hypothalamus is connected to what is called the pituitary gland or hypophysis. Now this is the pituitary gland, otherwise called hypophysis, another name for pituitary gland, hypophysis. It is connected to the brain through hypothalamus. So you have this one just below what we have, that is the cross formed by the optic nerve, hence called optic chiasma. So optic chiasma, hypothalamus, hypophysis. So hypophysis, the pituitary gland connected to the hypothalamus is connected to what is called the brain. So you could see all these 3 structures, optic chiasma, hypothalamus, and also there is hypophysis, the pituitary gland, only on the ventral side. On the dorsal side you cannot see, you can see only the pineal gland alone. Now it is enclosed in a bony structure called the brain box or the cranium, the brain, you know that one. So it is divided into forebrain, midbrain and hindbrain. So the forebrain includes what I mentioned, olfactory lobes, paired cerebral hemispheres and paired diencephalon. In the center of the diencephalon we have this actually the same structure here, the same one given in a diagrammatic manner, very simple one, the olfactory lobes, then the cerebral hemispheres. Then the thalamencephalon, the diencephalon is otherwise called as thalamencephalon. This is another name. And then we have the midbrain formed of the optic lobe. And we have just the medulla oblongata and then cerebellum. These are the components of the hindbrain. And we have the various nerves given actually. What are the different nerves given? Optic nerve. This actually olfactory nerve. The first one olfactory nerve. This is number 1. 10 pairs of brain nerves. This is optic nerve number 2. This is number 3. Olfactory, that is what is called oculomotor. This is number 4. Trochlear or pathetic. Then this is number, what we have, the 5th cranial nerve, what we have here, that is trigeminal. This is the 5th one. This is 5th one. And this is the 6th one, abducens. And this is the 7th one, the facial nerve. And this is the 8th one, auditory. Okay, this is the 9th one, glossopharyngeal. The 10th one, what we have, the vagus nerve. The 10th one represents somewhere here. Okay, that is here not represented. That's not in the diagram. So the vagus nerve. So we have 10 pairs of cranial nerves. The last cranial nerve is called as a vagus nerve. That's not represented. Okay, so only 9 pairs are given. So this is the arrangement of the nerves and also about what we call the olfactory lobes, all included. Both the central and then peripheral nervous system are included here. It's not necessary, you remember that one. We'll talk about the different types of nerves in human body. There you have 12 pairs of cranial nerves. 12 pairs. Now the midbrain is characterized by a pair of optic lobes. A pair of optic lobes I mentioned already called corpora bigemina. Corpora bigemina. The hindbrain I mentioned about 2 components, cerebellum and medulla oblongata. Now the medulla oblongata continued behind as what we have actually the spinal cord, which passes through a large opening of the skull. The large opening of the skull is called foramen magnum. So the medulla oblongata continued behind as a spinal cord, which passes through what we call the large opening foramen magnum of the skull. And the spinal cord is enclosed within the what is called the spine, within the vertebral column. The spinal cord is enclosed within the vertebral column. The brain is enclosed inside the brain box, and the spinal cord is enclosed within the vertebral column. Now, cranial nerves, I mentioned there are 10 pairs of cranial nerves similar to mammals. In the absence of spinal accessory, this is the 11th cranial nerve and the 12th cranial nerve which are being absent. These two are absent in the case of frog. But we have this 11th cranial nerve, spinal accessory, and 12th spinal nerve as hypoglossal. Now, spinal nerves I mentioned about, we have there are 10 pairs, what we said already in frog. Now, the first spinal nerve is what is called hypoglossal, which is normally the 12th cranial nerve in the case of man. Okay, so this is equal to the 12th cranial nerve in humans. In humans, the 12th cranial nerve is called hypoglossal, but the same nerve is called the 10th spinal nerve in the case of frog. Now, at the origin of each pair of spinal nerves on either side, normally the spinal nerves are arising on either side like this, actually 10 pairs. At the origin of each pair of spinal nerves are found certain calcareous glands. Calcareous glands. They are called gland of Swammerdam. Here, this is a gland. On either side of the spinal cord, at the place of origin of spinal nerves, we have a calcareous gland made up of calcium carbonate, and that gland is called, that is what is called Swammerdam. Gland of Swammerdam. So, gland of Swammerdam are present in frog. They are nothing but calcareous glands present on either side of the vertebral column at the place of origin of spinal nerve. So, at the place of origin of spinal nerve, on either side of the vertebral column, we have calcareous glands. These glands are called glands of Swammerdam. That's one question. What is glands of Swammerdam? Calcareous glands present in frog at the place of origin of spinal nerve. Simply remember that one. Now, the sense organs. We have different types of sense organs. In the case of vertebrates, generally you can see. Now, we have the organs of touch in the skin. They are called sensory papillae. Tactile sense organs are tangoreceptors present on the surface of the skin. They are called as sensory papillae. Now, we have the taste. The tongue, we have the taste buds. And for smell, we have the nasal epithelium in the nasal cavity. And also for vision, we have the eyes. And then for hearing, the animal has no external earlobe, but it has tympanum with internal ears. Tympanum with internal ears. The middle ear is highly reduced. Now, in the middle ear region, we have 3 ear ossicles. You know that one, 3 ear ossicles, 3 bones. But in the case of frog, the middle ear contains only a single bone, what is called columella oris. We have 3 ear ossicles in the middle ear, what is called malleus, incus and stapes. Malleus, incus and stapes are the ear ossicles found in human middle ear. But in frog, we have only one bone, what is called columella oris. Even the cochlea is also highly reduced. The name of the cochlea in the case of frog, so we have cochlea, the organ of hearing. In the case of frog, the cochlea is called as lagina. So we have cochlea, the main organ of hearing, found in the inner ear. But in the case of inner ear, the cochlea is reduced and it is represented by another organ called lagina and is similar to cochlea. So middle ear contains only one bone instead of 3, and we have the cochlea is reduced from what is called lagina. Now, this organ, normally you know that one, ears are concerned with the organ of hearing and balancing, equilibrium. So, we'll talk about all these things in detail in the case of human ear. This is only you have to know the differences. So, after the sense organs, eyes and internal ears are well organized structures, and the rest are cellular aggregations around the nerve ending. Cellular aggregation is collection of nerve cell bodies from which the nerves are arising. So, you can see well organized sense organs in the form of ear, and actually that's eye only. All other sense organs are in the form of aggregates of sensory cells from which the nerves are arising, either from the skin or from other parts of the body. Then the skeletal system. Now, if you compare the total number of bones with that of actually man, we have 206 bones, but here 53 bones less. They have 153 bones altogether. 153 bones altogether. Now the skull of frog is called dichondritic skull. I explained this one while talking about the classification. In the case of mammals and in the case of amphibian, the skull is dichondritic. So we have actually two projections arising from the occipital bones fitting into what we have just actually the axis bone for rotation. So that's why it's called dichondritic skull as in the case of human beings. Now the jaw suspensory, that is nothing but the hanging of the jaw. The type of hanging of jaw is different. So this is the lower jaw, how far it is hanging from the upper jaw. It is called autostylic. It's actually moving, suspensory, hanging, just what is called on its own. That is hanged by quadrate or jugal. There is a bone, quadrate and jugal fused together, and from where only the jaw is hanging. This is called autostylic, the hanging down from the bone. That is called suspensory. Now vertebral column is actually formed of 9 vertebrae plus 1 urostyle. Totally 10. You see that one? There are 9 vertebrae. 1, 2, 3, 4, 5, 6, 7, 9. And then there is a long actually rod-like structure, what is known as urostyle. So we have 9. What is the nature of the actually vertebrae? The vertebrae 2 to 7 are what is called actually procellus. What is the nature of the vertebrae 2 to 7? Procellus. I mentioned about what is procellus, amphicoelus, etc. while talking about the classification. Now the 8th vertebra is amphicoelus. Procellus, you have cavity and the anterior part of the centrum. In the case of amphicoelus, we have cavity on both the sides of the centrum. This is amphicoelus. So 8th vertebra. The 9th vertebra is acoelus. There is no cavity on either side. If you are taking the centrum of the vertebra, if you have cavity anteriorly, procellus, as in the case of 2 to 7. And if you have cavity on both the sides, concavity on both the sides, then it's called amphicoelus, the 8th vertebra. And you have no concavity, that is in the 9th vertebra, then it is called what is called acoelus, no cavities are present. The 10th vertebra is represented by what we call a long rod-like structure, what is called urostyle. Okay, long vertebrae, urostyle. So this is up to 1 to 9, this one, this is the 10th, this is the 10th. So this is up to 1 to 9. So remember the nature of actually. So the longest bone in frog is called tibiofibula, that is found in the shank region. So in the forelimb, you know that one, this is the forelimb, there are 4 digits. But there are 5 metacarpals. This is the palm region supported 5 metacarpals. But you see that one, in the case of that one, the first metacarpal is highly reduced and forms a structure what is called pollex. That is why we do not have actually the digit. This is the first digit, this is what we have, the index finger. Now the first digit is absent in the case of frog in the forelimb. But we have 5 metacarpals. But the first metacarpal connected to the thumb region is highly reduced, and that highly reduced metacarpal is called pollex. Now what is the digital formula? We have this is the first digit. Actually in the case of hind limbs, we are talking about the digital formula in the hind limb. 2, 2, 3, 4, 3. So this is the first digit 2, second digit 2, 3, 4, 3. So this is what we have the arrangement of what is called the digit, that is called digital formula. 2 phalanges, 2 pieces of bone, 2 pieces of bone, 3 pieces of bones, 4 and 3. So remember that one, the digital formula, 2 hind limbs, but forelimbs we have only 4. 2, just actually 2, 3, 4, 3. So that's about actually the various skeletal systems what we have. And so far we have completed what we have related to the frog. So the structural organization of earthworm, cockroach and frog over. Now we have to proceed towards what we have the human physiology, starting from what we have the digestive system from tomorrow onwards. Okay, thank you.